In this video, I'll show you how to solve the ALEKS problem called Understanding the Conceptual Components of the Enthalpy of Solution. This is a pretty tricky problem, so buckle up. I am going to walk you through the solution for this very specific version of the problem, and as we go through this solution, I'm going to be talking about the different variations of the problem, and I'll hopefully be giving you enough information that you'll be able to be successful no matter which version of the problem you get. So as the title implies, this problem is asking us about the energy associated with the formation of a solution from a solute and a solvent. It asks us three different questions, starting first of all with asking us to list the stages of the solution making process in order of increasing enthalpy. And it's referring to these four stages right here. In order to answer this question, we don't need to think yet about what our solute or our solvent is. We only need to focus on whether or not the enthalpy of the solution is positive or negative. So we got to think a little bit about thermodynamics. If we have a positive delta H, which I have, that means that I have an endothermic process, and an endothermic process is one where the products are higher in energy than the reactants. So in an endothermic process, our energy diagram looks kind of something like this. Energy or enthalpy, whichever one you want to think about, where these are the reactants and this is the products. And if you have a negative delta H, that means that you have an exothermic process. That's one where energy or enthalpy is released. And that is because the products are lower in energy than the reactants. So a diagram that maybe looks something like this. This is, we'll say this is a positive delta H reaction, and this would be a negative delta H. So this solution making process, even though it's not a chemical reaction, the solution making process can also be described by the same type of energy diagram. I'm going to make this one more dramatic. That. And we can think about the enthalpy of the solution making process the same way that we would think about the enthalpy of a reaction, where this starting point, pure solute, pure solvent, this is our reactants. So on our enthalpy diagram, our reactants, stage A, would be right about here. And in order to go from stage A to stage B, if you look at my particular problem, we can see going from stage A to stage B, this is where the water molecules are being pulled apart from each other. And this happens by the breaking of the intermolecular forces among the water molecules. So the water molecules, IMFs, are being broken and being pulled apart, and that requires energy. So that is kind of taking us on this uphill process in increasing energy. So stage B is going to be somewhere in the uphill process in our energy diagram. And then, now I do want to say as a side note, your stage B might not look exactly the same as mine. However, that's okay. Your stage B is going to have either your solvent being ripped apart, or maybe your solute is being ripped apart, one or the other. But either way, it requires energy to rip those molecules apart from each other. So stage B is always going to be higher than stage A. Now, going from stage B to stage C, you're going to see that the other substance is being ripped apart. And so by the time we get to stage C, our solvent has been ripped apart and our solute has also been ripped apart. Maybe not always in that same order, but either way, they're all being ripped apart. So again, ripping apart our solute compounds is going to require breaking intermolecular forces and an increase in energy, and we're just moving up this energy diagram. Now, going from stage C to D, this is where the solute and the solvent are brought together and new intermolecular forces are formed, and that's going to bring us down to the products, the solution, which is going to be, like, I did a really bad job of drawing this diagram. I'm going to relabel it a little bit right here and here. Now, we're being asked specifically to rank the stages in order of increasing enthalpy. And so that is just going to be kind of looking at where they lie on this enthalpy diagram. This is where my stage A ended up. I'm going to get that E out of the way. And this is where my stage D ended up. And B is here and C is here. So for a reaction that has a positive delta H, your stages in order of increasing enthalpy are going to be A, D, B, and then C. If you have an exothermic process, it's going to be D, A, B, and C in that order. So that's the first part of the problem. Whew. And now we're going to move on to the second question. The second question is asking, would heat be absorbed or released if the system moved from one stage to another? And you've got to pay attention to what ALEKS is actually asking you, because it's not always going to be asking you about going from stage C to D. It could be asking about going from A to B. Or B to D, or I don't know. So you've got to look specifically at what ALEKS is asking. And then once you've identified what is it asking, just read that off of the diagram. So mine is asking about going from C to D, which is a release of energy because I'm moving down the energy diagram. If it was asking me about going from stage A to B, whether it was exothermic or endothermic, I would say that that would be energy being absorbed. And I can't think of a situation where neither would be the answer, but if you have seen some different version of the problem where neither is the answer, then just please let us know in the comments about what that problem looked like and help everybody out. Then the last question, and this is the part where I think the problem gets exceptionally tricky, it's asking us about forces, and here it's specifically referring to IMFs. It's asking us about forces that are associated with moving from one stage to another. So again, I'm being asked about going from stage C to D. You're going to have to be careful because it could be asking about going from A to B or B to C, or it might say A to C. So be careful, and then once we've identified exactly which stages we're focusing on, we've got to think about what IMFs are involved in that particular transformation. Now, if you remember with IMFs, dispersion forces are always present. So dispersion forces will always be an answer to this question. And then also there are always IMFs present. So I don't think that none would ever be an answer. But again, if you end up with a problem where dispersion forces was not an answer, or none was an answer, just please let us know in the comments. Okay, so we've got to think, not only do we have to think about which stage we're in and what's going on, we also have to think, now is where we have to think about what the solute and the solvent molecules actually are and what intermolecular forces they experience. So going from stage C to D, in this particular process, and this is for, I have an ionic compound, NaCl, and water, H2O. Going from stage C to stage D, I am forming IMFs. And specifically, I'm forming IMFs between my solute, which is NaCl, and my solvent, which is H2O. And that is the intermolecular forces that I need to answer for this question. What are the intermolecular forces that get formed between sodium chloride and water? And that IMF is the ion dipole force. It would probably be helpful to go back and do a review of IMFs. I'm not going to go through all of them in this video because it would make the video take way too long, but this would be really helpful thing to review to answer this question. Now, one of the things that I do want to point out, and a place that I think you could get really led astray on this problem, is that you're only asked about the IMFs that are being formed in this particular process. So you might be tempted to think, oh, there's water present, and water always has hydrogen bonding, so I should check that as an answer. However, the hydrogen bonds between the water molecules are not being changed as we go from C to D. The water molecules are hydrogen bonded together in stage C, and they continue to be hydrogen bonded together in stage D. So they're not being affected by moving from stage C to stage D. We're only being asked about the IMFs that are changing as we move from one stage to another. And that, I think, is what makes this problem extremely tricky. If I had been asked about what IMFs are present as I go from stage A to stage B, I would notice as I move from stage A to stage B, what's going on there is that my water molecules are separating from each other. And then I would have to ask myself, what IMFs are being affected when the water molecules separate? What IMFs are present between water molecules? In that case, I would answer hydrogen bonding, dipole, and dispersion. That would be my answer. If I was asked about what IMFs are involved in this process, or it might say this way, which is where my solute molecule is separating. That's at NaCl. Then I would be asked, or I would be saying what IMFs are associated with breaking my solute apart. It's an ionic compound, so that would be ionic bonding and dispersion forces. Now, not all of our solutes are ionic compounds. Some of them are intact molecules. I'm trying to think of some of the ones that I've seen. Let's see, I saw CH3CN, which is molecular. It is not ionic. So that's, if it was CH3CN, we wouldn't have ions present, and we would be choosing different IMFs, like perhaps dipole forces. Covalent bonding forces, I don't think is an option. I think that that's referring to the energy associated with a covalent bond, which we're not breaking any bonds here. So I don't think this is one that you would choose. And the same thing with metal bonding. I didn't see any problems where this would make sense. So that's maybe a tip. But again, leave a comment if you did see that type of problem. And also, like, just be patient with yourself while you're working through this problem. It's really tricky, especially this last question. Remember, it's not asking you which IMFs are present. It's asking you which IMFs are changing as you go from one stage to another. Good luck. I know you can do this.